Okay, this is the May 2012 Paper 2, Problem 3, and this looks like it's going to have some geometry questions, and so you're going to want to turn in your formula sheets to make sure that you're in the right section where all those volume and surface area formulas are. So we've got a solid metal cylinder, and the base has a radius of 4 centimeters, and it's got a height of 8 centimeters. So let's just go ahead and draw our cylinder, and we can do that with a couple of ovals, and we'll just connect those ovals with some straight lines, and we have a beautiful cylinder. Now it tells me that the radius of that cylinder, that just doesn't even look right, does it? Why do I feel like the radius is a circle, so it really shouldn't matter, but we're used to seeing our radius looking like that, and it tells me that the radius is 4 centimeters and that the height of the cylinder is 8 centimeters. So it says find the area of the base of a cylinder. Well, what geometric shape is the base of a cylinder? The base of the cylinder is a circle. So what is the area of a circle? The area of a circle is pi times the radius squared. So we know that the area of this circle is pi times 16, or I'm going to just sneak that 16 in front of the pi. 16 pi. There's my answer. Exactly. We want to make sure for all of these units that we put the correct units. Centimeters area is a squared unit. Now you could write 50.3 centimeters squared. That would be correct, 3 sig fig. But if you can use an exact value, I think that you should lean that way. Show that the volume of the metal used in the cylinder is 402 centimeters cubed. So they're telling you ahead of time what the answer is, and what they're asking you to do with the word show is to just do exactly that. You want to show the formula with the correct values plugged in. So that was part A, and we're going to do part B. So the volume of any solid is the area of the base times the height. So we've got the area of the base, which is 16 pi, times the height, which is 8. So we've got 8 times 16 pi. I wonder how to make a little pi symbol with my, bet I got that on here somewhere. 16 pi, so that would be equal to we'll round that 402.123, so that's equal to 402 centimeters, which is what they asked us to do to 3 sig fig centimeters, and we want to make sure that we're showing that cubed. Alright, now in part C, we're asked to find the total surface area of the cylinder. So remember, the surface area of the cylinder is 2 circles, so 2 times pi times the radius squared. 2, and we've got pi times the radius squared. Well, the radius squared is 16, plus the surface area of the sides of the cylinder, if you will. So what is the formula for that shape? Remember, if you think about that being a piece of paper wrapped around that cylinder, it's really a rectangle, And what would be the length of the rectangle? Well, that would be the diameter of the circle. So the diameter of a circle is pi times the diameter. Pi times the diameter, which is 2 times the radius. So that would be 8 times pi. And then we want to multiply again times the height, which is 8. And so when we multiply that all together, our final answer is going to be 302 centimeters squared. Now you can always leave that exact. I want to make sure that we make that squared. So you can certainly leave that as an exact answer. So if you left it as 96 pi centimeters squared, that would be absolutely fine. In fact, if as your teacher, that would totally be my preference. So I'm just going to write or 96 pi centimeters. Oh, centimeters hopped up there. 96 pi centimeters squared. So that was for part C. In part D, let's see what happens. So now something else happens. We take the cylinder and we melt it down and we cast it into a cone. And here's our cone. The base radius is 6 centimeters. And it says find the height of the cone. Well, we're going to need to look at the formula for cones, and we're going to need to think about the information that we already have. All right, in part D, we're asked to find the height of the cone. So here's what we know. We know that the entire volume of the cylinder, which has to be the same as the volume of the cone, is 402 centimeters cubed, because we found that in an earlier part of our problem. So 402 is equal to, let me label this is part D. 400 is equal to, well, what is the formula for the volume of a cone? That's 1/3 pi times the radius squared times the height, which in this case, that height is equal to line segment OC, which is the thing that we are trying to find. So the amount of work that you have to show for IB is show the values plugged into the formula, just like that. In fact, I should make that radius equal to 6, because we know that that's equal to 6. And that's enough. You can do all the rest of the work in the calculator, and then you can say that line segment OC is equal to, and once you do those calculations, it's 10.7 centimeters. And that's at 0.7, sorry about that. 10.7 centimeters. All right, in part E, we're asked, what are we finding? The size of angle B. Did we find the slant height yet? Oh, no, that's in part F. So in part E, we're finding the size of angle BC. Oh, well, I would always, so we have this, that's a beautiful cone. There's our cone, and we want to draw that triangle. We've got B over here. And O's up at the, C's at the top, and O's in the middle. And the angle that we're trying to find, BCO, is this angle right here. All right, so is this a right triangle? Yes, it is. So that means that we can just use regular basic right triangle trig. And what pieces do we know? Well, we know that this is 6, and we know that this height is 10.66666. Use the unrounded value in your calculation. So what trig ratio are we going to use? Well, we know opposite over adjacent, so that means that we're going to use tan. So you've got the tan inverse, because we're going to be finding an angle of 6 over 10.666. Again, I apologize for how messy this writing is. I'm doing this on my laptop that doesn't have a mouse. 10.66. So that means our angle is 29.4 degrees. So you see how in this problem that started off we were doing volume and surface area. Now IB has snuck a little right triangle trig in. So that's very typical of a paper 2 problem. It's going to have lots of different topics. And we want to put the correct units of degrees onto that. All right, in the next part of the problem, we're asked to find that slant height, which is basically the hypotenuse of the triangle. And there are many, many, many ways that you could find that. Probably the easiest way would just be to use the Pythagorean theorem, using the two sides that you already know, the 6 and the 10.66. So doing the calculation that way, your answer would be about 29.2, but because of the various methods and various rounding, my notes say that the IB would accept an answer anywhere from 29.2 to 29.5. I'll just put 29.2, and again we want to have units there, so centimeters, and that's just regular centimeters. Okay, in part G, we're asked to find the total surface area of the cone, and again, surface area formula is given to you on your formula sheet. We're going to have the area of the curved part, which is pi times the radius times the slant height. Notice that we're oh, I gave you the wrong answer in the part before. That was from the angle, was 29 point. They would accept 29.2 to 29.4. The slant height was 12.2 centimeters. And then to find the curved area, we take pi times the radius times the curved area. Use the unrounded value. So I'm going to do pi times the radius times the unrounded 12.2674 plus, so that's the area of the curved surface, plus don't forget that to do the entire surface area of the cone, then you also have to include the area of the base, which is that circle, pi times the radius squared. So that gives me pi times 6 squared, which is pi times 36, and giving me a total surface area of 344 centimeters squared. So my surface area units are squared.